This is Jess, and I'm going to take us through our capstone app called Foodable. We chose Foodable because so many individuals struggle with making good food choices, and this app will give folks the ability to make better decisions as well as have accountability from others. There were 5 main features of our app. Users can find local stores that have affordable food. They can look up dietary information for a specific food, create recipes, as well as a grocery list, and they can also interact with others on the platform. Some technologies we used were React, because everybody had familiarity with React and it was quick to build with. We also chose Fast API, which uses Python, which we're all familiar with. And we wanted experience with asynchronous development. We also chose Supabase for both Postgres and authentication because it was super easy to use. We didn't have to build auth from the ground up. We also used the Claude API, which we felt was slightly less evil than the OpenAI API. Google Maps API for the grocery store search. We use Render for hosting. So my parts of the project included a database design and DML, setting up the Supabase auth, as well as building the search backend, which is where you can input a zip code as well as a specific food you're looking for. When you hit search, it calls the Google Maps API to search for local stores that would carry the item. And then that information is fed into Claude, which writes a little more information about the store. And then the information from Claude, as well as some of the specific info from the Maps API, like whether the store is open or closed, the store hours. That is then sent back to the user and displayed in here. We more or less stuck to our original plan, but we did replace SQL Alchemy with Supabase since Supabase was very well documented and we were already using it. Also, the search front end was originally split between Scott and I, but he ended up taking all of it, which freed up my hours for the prompt engineering and learning the Google Maps API, which took a lot of time. Some of the challenges we faced were a lot of what I had to do in the beginning was blocking the entire team. So I kind of moved things around so that I could get things done as quickly as possible so that others could continue their work. Another issue that was challenging was we had a lot of overlap in the features we were developing, but I think the team did really well in using a well-defined and documented Git workflow. So one of the things I learned was vendor lock-in. Supabase had a great product and we were using it, and then we were using their SDK, and pretty soon our entire backend is pretty reliant on it. So had this app gone into production and they raised their prices, then we're at their mercy. Also, using the web search for LLMs eats tokens rather quickly, which is what made us shift to the Google Maps API. And prompt engineering is very tedious. There's a very large trade-off between either having no results or having results that are inaccurate, not to mention the financial trade-offs of what model to use.
Hello, this is Scott Dispensa. I'm going to give a brief overview of my part in our project Foodable. So I did mostly deal with the front end. In doing login and profile creation, Jess and I kind of had a tag team because there was much more sort of interweaving of responsibility in back end and front end with that portion. But then when we moved on to the search page and then to social media, I primarily did deal with the front end aspects of it. This was a great learning process. Let's see, let's talk about my parts of the project, which were, those three things. The search was very interesting. For me, that mostly involved rendering the initial state, which I'll show here, and then what happens when something is pulled. So basically, all of the buttons, all of this. The left side banner was actually the Tony who did the navigation on that. Um, and so then the sort of rendering of the directions, which would pull up a Google Maps to the address here, and then the hours toggle. And, we can have up to, I believe, 7 items pulled up there. The development steps, were mainly what we did is split into the teams of 2. And so I was on a team with Jess for the majority of the time, and we did our sort of 3 components together. And the original plan, it wasn't too different, other than the fact that the homepage, which initially was just an actual homepage, became the social feed. And so, as you can see, that kind of ended up as the landing page, instead of the original idea to have an actual homepage. We did try to use this magic link system for sign in, but we decided that it was too cumbersome. It only allows 2 sign ins per hour, which just wasn't sufficient for development. So we went back to a password implementation. Um, the there were many challenges. I could probably list more than I did here, but mostly it was kind of getting the structure right and getting the big pieces in play. And then once you kind of got the hang of working with React, it became much easier. And then of course there was troubleshooting for when things would inevitably break. Using Claude Code sort of in tandem as like a learning tool was really, really great, in just sussing out, what are the potential problems here, ideas for testing, ideas for development. Sort of large scale structures were great. We had an amazing team, and we really worked well together the whole time, and that was absolutely the best part of this process. In closing, I'll walk through the social media. So basically, this has a few parts. Your feed, if I created items, which I haven't in this account, but if I created a recipe or grocery list, they would appear here first. Then other people's recipes and grocery lists appear here next. And then your friends that you're already following are here under friends. But then if we clicked find more friends, it would be the rest of the people that are in the user database itself, and you can follow and unfollow them. And then when you follow them, it will add anything that they've created into this feed. So that's kind of nice. And then if you like somebody's post, it will increment their points here, and it will. They kind of have a level, which is like the icon next to their name will change. Um, and that is basically it. Thank you very much.
Hey you guys, this is Tony. So for my part of the project, what I did was that I built the front end foundation. What that means is that I built our reusable component library for the most part. I also helped co-develop the recipe and grocery list features of our Foodable app to utilize the AI integration. I also handled the backend router work to some degree for both of these pages, along with the socials feature that Scott did. And I also wrote tests across the stack. Everything I've done, I was using it in the technologies that the rest of my team was using, so that way we can all stay aligned in sync together. So this is an example of feature that I did. This is the grocery list page. This is a page where a user can use our app to create a grocery list, either manually or with an AI. For this example, I'm going to show it as if a user is creating it with an AI. So if the user provides some information to the AI returns a response, which the user can save. The saved grocery list will then persist in Supabase database persistently. Now, another example I wanted to show is the test suite that I did. So for the front end of Foodable, I created 28 tests, whereas for the backend, I created 14 tests. For the front end tests, most of the tests is primarily testing for the components to make sure that they do not break over time. And if they do break, then we at least know what to do to fix them. Whereas I also made a unit test for our point bank leveling system. As the backend, I created integration tests, meaning I created tests that test to see if the whole application properly pings Google Map API, Claude AI, Superbase API to make sure that it's actually working as if it's production live. And then I created mock tests to basically replace these integration tests, mainly because the integration tests they actually make live API calls, which is not free. So that's why I made the mock test. Now, when it comes to the development process on my end for Foodable, I plan each task by talking it through first with Cloud Code as my rubber ducky. I also worked in isolated branches, and I also created pull requests. So that way my colleagues, my team members can review my code and then approve the code, and then they can merge the code into the main. So that way I'm not going to mess with the main branch until someone else has laid eyes on what I've done so far. Challenge that I had is that my newborn daughter, she arrived earlier than expected. So the timeline shifted for when I was able to get the tasks assigned to me for me to complete those tasks. Thankfully, I was on paternity leave with a lot of late nights, persistence, and caffeine. I was able to get all of the tasks assigned to me done regardless. And one of the biggest takeaway that I've learned so far is that Cloud Code is a generally effective soundboard. I use it to help me think my thoughts out. I use it to help me understand the technical documentation, the technical jargon of different languages. It is extremely useful tool to help me learn a lot quicker and faster. So, of all the things I've learned, Cloud Code is amazing just for that alone. But other than that, that's it for my part. Thank you so much.
Hi, I'm Ying. I worked on the nutrition and recipes feature for Foodable. The food lookup page is where users can search for any food and see its nutrition breakdown. I built the backend endpoint that calls Claude to analyze the food and return structured data in JSON. I also built the backend routers for recipes, so users can either manually create a recipe or type in a food in the prompt and Claude generates the recipe. The tricky part of this feature is handling the Claude response. For example, parsing the JSON, validating it with Pydantic, and saving it to the database. I also built the error banner component for displaying errors and refactored the overall visual design to make everything look consistent and polished. Next, I'll show you what it actually looks like. Here is the dietary information page. I'm going to find out the nutrition information about 1 cup of oat milk. And here is the nutritional breakdown coming back. We see the calories, carb, protein, and fat. All of that is being generated by Claude on the back end and returned as JSON. And I'll show you the recipes page. You can manually create a recipe by filling in the name, description, and the ingredients one by one. The cooler part is the AI generation. So if I want a recipe of blueberry, I can just type blueberry in the prompt section, and AI will generate a recipe of blueberry muffins for me. So that's pretty much what I built. The nutrition lookup, recipes with both manual and AI generation, and some supporting pieces that make the web app work smoothly. Overall, everything stayed on track. We plan to split the work by feature area, and that's exactly what we did. The one challenge early on was visualizing how everything would come together with two separate repositories for front end and back end for people working on different features. But as each pieces landed, things started connecting, and by the end, it all integrated smoothly. The key takeaway I had from this project is that clear communication with teammates was huge. And when working with LLM APIs, you need defensive coding. You need to use JSON schema to constrain outputs and wrap parsing in error handling, so bad responses don't crash the app instead of breaking everything.